again, everybody. Lesley Curwen here again from Business Daily. I've got more FiReStarters for you, more amazing, fantastic companies. So let's start off quickly with Morphlabs and Winston Damarillo, who's the co-founder and CEO of Morphlabs. Winston, tell us about your company.
Thank you, Lesley, and it's great to be here this afternoon. Morphlabs is a cloud computing company, and we're specifically focused on the infrastructure. We got started in 2007, being really fascinated with what Amazon's new cloud service brought to the table, and that was providing programmatic access to what seemingly is infinite amounts of computing resources, and that means computing and storage in general. And as we built up the company, we were very interested in what this will do to the IT landscape in general. We observed the United States and figured out that this has become kind of a new anchor platform for entrepreneurship and even large enterprise starting to move into this. With Morphlabs, that fascination translated into the idea of, or the thinking of, will the rest of the world connect to the United States service, or is this particular technology ideally regionalized? And so from that standpoint, what we did was we took the example of the Amazon cloud computing AWS service and vectored it to developing countries. So we looked at the technology, we've replicated not just the hardware stack, but also the software stack, and then explored its potential in developing countries like the Philippines and Indonesia and Singapore and Malaysia and Japan, and found out that not only was it very relevant to the emerging countries in the region, but also it brought in substantial and more interesting innovation as well in terms of how computing is even more scarce in this country, and cloud computing can bring in so much more into these countries than here in the US. And we know we brought in some interesting changes with what Amazon started with, and introduced things like solid state storage to save power. We've helped found and continue to build technologies in open source like OpenStack, and have really gotten to deliver the infrastructure that was very prominent here in the United States and Europe into developing countries in Asia, and consequently enable that market to have what we have here in the US, which is the advantage of readily accessible, low-cost computing, and have been building the company since. We're very excited about the prospects. We're seeing applications that's not just pure IT, but it's now become a backbone for educational systems in the Philippines, for example, as well as its potential to really democratize access to computing in countries where they have so few resources to begin with and experiencing significant growth. And these are, Asia is a good example, but it's been replicable for us for most of the next 11 emerging countries.
Okay, great. Thanks very much to Winston Damarillo from Morphlabs. And now Tony Lammers, who's the president and CEO of MAR Systems. Tony, tell us about your company.
Sure. Thank you very much. Thank you for the opportunity, and just want to say we're very excited to be at FiRe. Just to sort of connect us a little bit to last night, a lot of conversation about Albert Einstein. One of my favorite quotes from Albert is that he said, "We shall require a substantially new manner of thinking if mankind is to survive." Now, he was a long time ago, and he was a whole different set of problems that he was focusing on. But water is so important that I have sort of co-opted that quote and really use it whenever I talk about all things water. So MAR Systems Incorporated, we're a Cleveland, Ohio-based clean water technology company. We are not in the water business per se. We don't buy water from anybody. We don't sell water to anybody. Our business is really removing contamination from water streams. We say contamination very broadly. We're really focused on heavy metal contaminations, heavy metals being defined in our world as mercury, selenium, arsenic, hexchrome, a few non-metals such as fluoride and things like those lines. Why is that important? Well, I had a very brief conversation with Roger Payne a little earlier today. Don't want to steal his thunder, but and he'll talk about it a little bit later, I'm sure, that A lot of his, he's studying contamination in whales, and a lot of the contaminations that we're focused on are showing up in whales who have, living their lives a long way away from any industrialized community. So it is a global problem. The metals that we remove are the things that you really don't want in your water streams. And they're all, or most of them, are in the bioaccumulative categories. So the only way to reduce their levels in the environment is to continually reduce the levels that are being discharged into the environment. The other thing that we say that we sort of bridge that conflict between industry and the environment. If you're an industry, or if you're a community that has an industry in it that's a discharger, eventually you're either going to force him to solve his problem or throw him out of your community and the jobs and everything that go with that. So the pain is real. Companies have to fix their discharge problems. Our technology was developed along with the US EPA. They're co-inventors of our technology. We've actually licensed back our own technology from the US EPA, so that we're the sole licensee of our own technology. We have 3 issued patents. We have a couple of pending applications. What we've developed is a new, innovative, and proprietary media, and so essentially you put contaminated water stream in contact with our media. The contamination actually gets chemically bound or covalently bound to our media. It's a single-use media, and the advantages are significant ease of use, very, very high capacity, and very, very quick contact time. And if you know anything about water wants to move. If you have to stop it for any length of time to do whatever it is you're going to do to it, you have to build vessels to hold it. So certainly the advantage of our media is that you just stop the water, you use a lot less material, you have to build smaller tanks and things along those lines. We're treating our contaminants down to the single-digit parts per trillion level. Mercury, if you're in the Great Lakes area, which our company is based in, the discharge level is 1.3 parts per trillion. That's awfully low. We're really one of the only technologies that allow a discharger to get down to that single-digit parts per trillion. Selenium, we're actually doing some work here in Orange County. The Orange County, California bit limit is less than 2 parts per billion, again, remarkably low, and we seem to be the only technology that can help a discharger get to that particular level. If this is a technology conference, a lot of device manufacturers, might have fluoride discharging as a concern of theirs. We certainly can help in that regard. So that's sort of the wrap up of our technology. We are, what we're looking for is continued introductions to industrial streams that we might be able to go to work on. We are also looking for investors in a Series C round of investing.
Tony Lammers, thanks very much indeed from Mars Systems. And now on to Simavita, and Philippa Lewis is the CEO of that Australian company. Philippa.
Thanks, Lesley. Yes, I am Australian, you can tell probably from my accent. So I want to tell you a little bit about our company, Simavita, and this stunning new technology that we've developed. We're in an area that's very exciting when it comes to healthcare. It's in the aged care sector of healthcare, but in an even more exciting part of that part of the healthcare scene, and that is an area of adult incontinence. So for those of you who don't know what that means your inability to control your bladder or bowels or both. So I've got 5 minutes to get you excited about human excreta, and I can tell you I'm excited about it. So bear with me, and I think by the end of 5 minutes you too will be very excited about the notion of human excreta and what it means. So we have developed a technology that embraces all the things that everyone's excited about here. It's wireless, it's about sensors, it's body worn, it's continuous monitoring, it's cloud computing, it's all the things that we're all excited about. But what's really important about the area that we work in is that it is this area of ageing. And we have this huge, as was said this morning, tsunami coming of ageing people, and a GDP that can't cope with the costs of healthcare, and particularly the healthcare of ageing people. When you drill it down to ageing and actually adult incontinence, it's the single most expensive part of the care of an ageing person. So right now around the world it costs about $9 billion to look after your incontinence if you're in long-term care. The rest of the market, if you like, in terms of adult incontinence if you're old, is another $9 billion. Now, because we have such a huge growing ageing population of people, this particular disability of incontinence is going to grow exponentially, just like the demographics. And the reason for that is, you may not be aware, but actually adult incontinence is a very ubiquitous disability for people when they get old. In other words, if you live long enough, you will become incontinent. So whilst you may think you're in full control right now, the future is looking grim, but thankfully there are technology companies like us that are forward-thinking and forward-looking enough to say this is a big problem, a huge cost area, and something that we really have to do something about. We have to do something about it both from an economic perspective and also from a human suffering perspective. So you have this huge growing cost in an area of care, the biggest single cost for your care when you're in a long-term facility. But more importantly, on the social side of things, of course, none of us want to go into long-term care, do we? I don't know anybody who would ever sit here at this point in their life and say, I dream of going into a nursing home. It's where I want to end. None of us want to go there. And even when we get there, we don't want to be there. So how do we stop from getting there? Well, then you have to target the high reasons for why you'll go into long-term care. If you develop dementia, you will go into long-term care, most likely. If you develop incontinence, you will go into long-term care, most likely. So it's in the top 2 reasons why people are put into long-term care now. So when we talk about the cost of healthcare and the cost of ageing people and what are we going to do in the next 30 years, we have to tackle the areas of cost that are really going to make a difference, the material areas. So the 2 areas are cognitive impairment and incontinence. And not a lot of people know that about incontinence, but that's the big news that we bring to the FiRe, and that is that this is an area that has to be focused on, and we think we have the solution. So just a little bit about what we have. We've embedded a sensor into an adult diaper. That's the product that you wear when you're incontinent. And if you want to think of anything that's most body-worn, most likely to be body-worn in a sensor area, it's in a diaper. It's not around your neck or your wrist or anywhere else. It's in your diaper because you're going to be wearing one. So we've embedded the sensor, and through a wireless platform, we transmit a whole lot of data to a software program with some clever algorithms, and it creates a very exciting outcome for you. The most important thing is 2 things. It cuts the costs of your care when you have incontinence, both in deployment of labour and the consumables and a whole lot of other correlated conditions around your incontinence. And the second thing that it does is it completely changes the landscape for you if you are incontinent. So one thing, for instance, we've been able to prove with this technology is many people who we think are incontinent are not incontinent. Many people who shouldn't be treated in a certain way or with care protocols, we're doing exactly the wrong thing by these ageing people, and it's costing a fortune for us to get it wrong. So what our technology does is it creates a whole lot of data and information in an area that previously was a desert of knowledge. We had no knowledge of what this condition was all about. Now we know an awful lot about your incontinence through this technology, because finally we're able to actually understand why you're incontinent, when you're incontinent, how you're incontinent, and how we can actually manage that. And that has a huge effect on costs. So we're all about taking costs out of healthcare and creating a much better future for ageing people with a disability that unfortunately we'll all face as we get older. So that's our story.
Philippa Lewis of Simavita, thanks very much. Okay, so Davis Brimer, who is the founder and CEO of Active Life Scientific, over to you.
Thank you, Lesley. So Active Life is a maker of a new medical technology called reference point indentation that is able to quantifiably in vivo measure biological material strength. And that might not make much sense right now, but I'm going to convince you that this is going to help solve hundreds of billions of dollars of healthcare costs to our nations. So if you think over the past century, and then perhaps even look around this room, it's no surprise that we are getting older. Medical technologies over the past 100 years have absolutely succeeded at allowing us to age. what I call extending the quantity of life. However, if you think about the aging population and what comes along with that, so some of the things that Philippa mentioned, but also musculoskeletal problems. So think to yourself, how many people do you know who have had a hip replacement, a joint replacement, so a new knee or a new shoulder? And think of the costs that are associated with that. I'll throw a cost out there for you. So in the US alone, in 1 year, the direct and indirect costs of musculoskeletal healthcare is over $800 billion. That's a lot of money in the US alone. So I would challenge the medical technology that's been used today, not that from the perspective of extending life, so helping us live longer, this quantity of life consideration, but focusing on the quality of life. What we have used up until today really has failed us. If it were working, we would still be going down the ski slopes at 90 years old. So what about this concept of biological material strength that I mentioned? I'll give you an analogy. Think of a surgeon going in and doing an operation on your knee or your shoulder or your hip. I'll put $20 on the table that 9 out of 10 surgeons would tell you that they assess the quality of that joint, of that bone, of that cartilage by touching it. And what they'll tell you is, I can tell if that screw's going to hold or if that bolt's going to stay in place based on how mushy or how stiff that bone is. And that's great. That's great. But unfortunately, mushy is not a metric in medicine. So while that is helping make assessments on an individual basis, unfortunately, we can't diagnose and we can't treat based on a subjective measure of mushy. So understanding this concept, a physicist and inventor at the University of California in Santa Barbara named Paul Hansma, who's best known for his past inventions on the atomic force microscope, which helped to enable nanomedicine and atomic imaging of life science materials. Understanding this concept, he used his understanding of nanoscience and microtechnology and microinstrumentation, combined them together and essentially shrunk down this concept of the surgeon being able to touch a tissue and know if that tissue is good or bad into a percutaneous microscopic wire that can enter into the body no more invasively than a blood draw and get a quantifiable measure of the strength of the tissues inside of our bodies. So thinking about how all this wraps together, Active Life's technology is literally quantifying how strong the tissues in our bodies are. This is a direct measurement. Whereas the standard technologies that are used today, based on what has evolved over time, is advanced imaging. So if you think about if you have a shoulder pain or a knee pain, the first thing they'll do when you go to the doctor is take an X-ray or an MRI or a CT. Perhaps there's a second thing. First, they'll ask you a few questions to make sure you qualify for the payment before they do the test. However, if you think about what's really the problem here, I want to know, is my knee going to fall apart if I'm walking down the street? If I fall over, is my hip going to break? I don't care what it looks like. It's not that I want you to take a picture of it. I want you to tell me how strong it is. So Active Life's reference point indentation is directly assessing one of the most important questions when you're trying to answer this question. So I'll say it again, what I said in the beginning, that Active Life is the maker of a new medical technology called reference point indentation. That's the first ever available in vivo quantitative measure of biological material strength.
Davis Brimer of Active Life Scientific, thank you very much. Audience, you must have some questions for these amazing people. Anybody out there? Okay, well, I've got a question, I think, for Philippa. How big a market is there potentially, do you think, for what you're making?
So we have our first product, and the market potential for that product is $18 billion. And that's a combination of long-term care in developed countries, and also people living at home who are trying to stay at home. So that's our first marketplace for our first product.
And how much will it cost?
That's a great question. It'll cost a lot less than the way you do it now. In terms of the technology, our costs are really, like all electronic businesses, it's coming down with volume. So currently what you do in a facility is, for example, or if you're trying to stay at home, is you conduct an assessment of that person. And the cost of doing that assessment when you're incontinent is very expensive, very time consuming, and it costs a lot of money. So if you replace that with instrumented assessment activities, it's very much cheaper.
Okay. Tony Lammers, unless anybody else has got a question. Any questions out there? Oh, yeah.
I don't know if this is on. Now it is. I wanted to ask for Morphlabs. You mentioned that the cloud structure was being used to support educational applications in the Philippines. If I heard you right, can you say a little more about that?
Yeah, so the Philippines is a fast-growing country that's got about 100 million in population, and have just decided to move from K-10 to K-12. So we're adding 2 years in the educational system in the Philippines, and that's taxing an educational infrastructure in the Philippines that today already have 44 students per classroom. And so what they're trying to do to address that short-term, very big need is to increase the amount of time students are in the classrooms. They actually have 3 shifts in the classrooms now, but then augmenting that with a technology called CloudTop. And CloudTop is the equivalent of what we call a virtual desktop environment here in the US. So it basically puts course curriculum on a tablet, and those course curriculum are now then distributed within a content management system that runs on the cloud. So that's precisely what we're trying to do there. What's interesting about what we have with the US or the developed country technologies like virtual desktops and cloud computing is that in developing countries where computing is very, very scarce, that's actually a national resource for them. And so whereas we use it here to build companies like Facebook and Twitter, countries like the Philippines are using it so that they can augment educational systems, right? So they can lower the cost of delivering education, and so that they can, enable this move from K-10 to K-12 in those environments. And that's what we find fascinating at Morphlabs, is we're able to package technologies that is built and invented here in the United States, package it in such a way that it captures both the technology and the know-how of delivering cloud computing, and then distributing that to the rest of the world. But it works extremely well in the Philippines, and we're starting to replicate that in other developing countries.
Any other questions out there? If not, Tony Lammers, I've got a question for you. What kind of organisations do you think are going to use your services? Are these big industrial concerns?
Sure, thank you. That's a great question. Our current client base is really a number of industry verticals, certainly very much large corporations, the refining industry, coal mining industry, the coal-fired power plant industry. Anybody who's really in the extractive businesses are all, have metal contamination as concerns that they're trying to deal with in their wastewater treatment facilities. We're very much tied to, things like, the Canadian tar sands we all hear an awful lot about. They come with, metals as a byproduct, certainly mercury, selenium, and things along those lines. So we are very much in the wastewater business, and we are doing business in pretty much all of those verticals that we're talking about.
Davis Brimer, I've got a question for you. Are surgeons going to make decisions based on the kind of data that you'll give them, which is presumably it's kind of effectively it's going into tapping the surface of the bone, is that right?
Right, so that's ultimately one area that this technology will be and is being used currently in more of clinical studies rather than actually to diagnose patients. So it's this concept that before we talked with many different surgeons and asked them, how do you know when you screw this screw in that screw is going to hold the plate in? How do you know in the shoulder, for example, it's a very difficult surgery to do, whether to insert hardware, which is screws and plates and bolts, or how to just replace, if you know to just replace the shoulder. And they say it's extremely difficult to know because there's not much material there. So it's a concept where the industry standard way of assessing bone health is looking at how much calcium is in the bone. But in an instance where there's not much bone to begin with, they really don't have much to go off of. It's a very subjective measure, and they often have to be extremely conservative. So what they're investigating, and there's several studies going on in Europe right now, is based on the numbers that this technology gives. So by going in and microscopically, by about the width of a hair, actually poking the fibers in the bone and getting a number from that can indicate how to make that decision and lead to better results.
Fantastic. I could carry on asking all of you questions all afternoon. There's just so much to ask you. But that's the end for the moment. So thanks very much to Davis Brimer from Active Life Scientific, to Philippa Lewis from Simavita, to Tony Lammers from Mars Systems, and Winston Damarillo from Morphlabs. Everybody, please show your appreciation.